Hey everybody, welcome back. So today we're going to talk a little bit more about integrating, but finding the exact equation that we integrated into. So here we've got an equation, let's say 3x squared plus 2x plus 5. If we take the derivative, we get 6x plus 2. But if you have 6x plus 2, the closest you can get to finding this exact equation would be just the 3x squared plus 2. The plus 5 is more of a starting point. It doesn't tell us anything about the slope. Remember, our derivative only tells us what the slope is at any point, or the gradient if you're over across the water. Okay? So there's that problem. Well, if we want to go backwards, we have to know one extra piece of information. We have to know a point that it contains. All right? So let's say we have this equation, 4x cubed minus 3. Sorry, 4x minus 3. We know that the function, not the derivative, but the actual function contains the point 5, 4. We want to know what is the original function. Well, let's start off by integrating this, okay? Taking the antiderivative. F of x would be, let's start off by making the x an x squared. We got to put an x on there. 2 times what makes 4? 2 times 2 makes 4. 1 times what makes negative 3? Negative 3. Then we have a plus c on the end. Okay. Now is where this point comes in handy. Here we have an x value and a y value. So we take that x value, we plug it in. 2 times 5 squared minus 3 times 5 plus c equals 4. Hey, could we solve this to figure out what c is? Yeah, let's do it. Okay. So 2 times 25, 5 squared is 25, is 50. Minus 15 plus c. Let's see here, this is 35, so let's subtract 35 from both sides. Looks like c would have to be negative 31. So the original equation here would have to be 2x squared minus 3x minus 31. That would be the original equation that if you took the derivative would give you this slope, but it's also the only equation that would contain that point. Let's try another problem. All right, let's try this problem. We have a derivative of a function. Its derivative is 5x minus 6. We know that the original equation, f of x, contains the point 1, 8. We want to know what is that equation. Well, let's start by integrating f of x. Let's see here, we're going to get an x squared, an x, and a plus c. Let's see, 2 times what is 5? Ooh, 5 halves. 1 times what is negative 6? Negative 6. Well, let's go through, let's plug in that 1, 8. So we've got 5 halves times 1 squared minus 6 times 1 plus c equals 8. 1 squared is 1, so what's 5 halves minus 6 plus c? 5 halves minus 6, well this is 12 halves. What's 5 minus 12? It is negative 7 halves plus c. See, in order to get rid of the minus 7 halves, we need to add 7 halves to both sides. 16 plus 7 is 23 halves, which is 11.5. There you go, so we get rid of the c there. We write in 11.5. And you're done, okay? It wasn't hard to go through and figure out what the answer was. Let's try another one. All right, here's a slightly trickier problem. We have the derivative of this function is 6x squared plus 2x minus 4. We know the function contains the point 5, 2. We want to know what was the original function. Well, first let's start off by integrating. We have an x cubed. We're going to have an x squared. We're going to have an x. We're going to have a plus c. 3 times what is 6? 2. 2 times what is 2? 1. 1 times what is negative 4? Negative 4. Cool. Now what do? We just take that point and plug it in. 2 times 5 cubed plus 5 squared minus 4 times 5 plus c equals 2. Let's see here. This is going to give us 5 cubed is 125. 125 times 2 is 250 plus 25 minus 20 plus c. Let's see here, that's 5, so 255 plus c equals 2, minus 255 from both sides. That leaves me with negative 253 equals c. There we go. All right, I'm going to put another one up. I want you to try this next one on your own. Here you go. I want you to find the initial value for the equation where the derivative is 9x squared minus 8x minus 3, and the equation contains the point negative 3, 2. What is that equation? Pause the video, give it a try. All right, you should have paused the video. You should have your answer by now. Let's give this problem a try. Let's see here. First, we're going to start off by integrating. We've got f of x equals something x cubed, something x squared, something x plus c. 3 times what is 9? 3. 2 times what is negative 8? Negative 4. 1 times what is negative 3? Negative 3. Next step, I go through and plug in my point. 3 times negative 3 cubed minus 4 times negative 3 squared minus 3 times negative 3 plus c equals 2. All right, here we go. This is going to go through negative 3 cubed. That's going to give me negative 27. 27 times 3 is negative 81. 4 times 9 is 36. Negative 3 times negative 3, that's positive 9 plus c. Let's see here, negative 81 minus 36. That's going to be negative, let's see, we've got a 7. 3 plus 8 is 11. Plus 9 plus c. That gives me negative. So here, if I add 108 to both sides, because these add up to negative 108, I'm going to add 108 to both sides. And you get 110 is the value of c. Cool, cool. If you got that one right, great. If you think I did it wrong, harass me, let me know. If you did not get it right, I want you to try one more. Here you go, give this one a try. Pause the video if you need to. All right, you should have paused the video by now. Here's the answer. So, the derivative of an equation is 3x squared minus 2x minus 1. We know that the equation contains the point 2, 3. We want to know what the equation is. Here we go. So first I'm going to start off by integrating. That's going to give me f of x is x cubed, x squared, x plus c. 3 times 1 is 3. 2 times negative 1 is 2. 1 times negative 1 is 1. Sorry, it's negative 1. There you go. We're going to plug in the 2/3 now. So we've got 3 equals 2 cubed minus 2 squared minus 2 plus c. Let's see here. That's 8 minus 4 minus 2. So 3 equals 8 minus 4 minus 2 is 2. 3, 2, and minus 2 from both sides. 1 equals c. There you go. So we take that c, we can plug it back in. So your technical answer would be f of x equals x cubed minus x squared minus x plus c. Sorry, plus 1. There you go. Cool. There's an assignment there in Canvas. Give it a try. Holler at me if you get any questions. The rest of the time is yours. See you guys.